Download this code from codegive.com, link in the description below. OK, let's dive deep into project duration estimation with the PERT method. This tutorial will cover 1. Understanding project duration and its importance. 2. Introduction to the PERT, Program Evaluation and Review Technique, method. 3. PERT formula explained. 4. Estimating activity durations, optimistic, pessimistic, and most likely. 5. Creating an activity list and dependencies. 6. Building the network diagram, optional but helpful. 7. Calculating expected activity durations and standard deviation. 8. Identifying the critical path. 9. Calculating project duration and standard deviation. 10. Probability of completion within a specific time frame. 11. Addressing common challenges and limitations. 12. Code example, Python, for PERT calculation. 13. Advanced considerations and extensions. 14. Conclusion. 1. Understanding project duration and its importance. Project duration the total time required to complete all activities of a project, from its start to its finish. Importance planning and scheduling essential for creating realistic project schedules, allocating resources, and setting deadlines. Resource management helps determine resource needs, personnel, equipment, budget, at different stages of the project. Risk management inaccurate duration estimates can lead to delays, cost overruns, and project failure. Knowing the range of possible durations is critical for risk assessment. Stakeholder communication provides a basis for communicating project timelines to clients, management, and team members. Performance measurement enables tracking project progress and identifying potential schedule deviations. 2. Introduction to the PERT, Program Evaluation and Review Technique, method. PERT is a statistical method used to analyze and estimate the time required to complete a project when the individual activity durations are uncertain. It's particularly useful for projects with complex tasks and dependencies where precise time estimates are difficult to obtain. It's based on a probabilistic approach, considering the range of possible activity durations. Key features of PERT probabilistic estimation uses 3 time estimates for each activity, optimistic, pessimistic, and most likely, to account for uncertainty. Weighted average calculates a weighted average of the time estimates to determine the expected duration for each activity. Critical path analysis identifies the critical path, which is the sequence of activities that determines the shortest possible project duration. Any delay in activities on the critical path will directly impact the overall project completion date. Variance and standard deviation calculates the variance and standard deviation of activity durations and the overall project duration, providing insight into the potential variability in project completion time. Probability assessment enables the calculation of the probability of completing the project within a specified time frame. 3. PERT formula explained. The core of PERT lies in calculating the expected duration, TE, of each activity. Where TE expected duration of the activity. A optimistic time estimate, the best case scenario duration. M most likely time estimate, the most realistic or probable duration. B pessimistic time estimate, the worst case scenario duration. Why this formula? The formula is a weighted average, giving more weight to the most likely estimate, M. The optimistic and pessimistic estimates are included to account for the range of possible outcomes. The 4 in the 4m factor implies that the distribution of possible durations is approximated by a beta distribution, which is commonly used in PERT analysis. Variance, sigma superscript 2, and standard deviation, sigma. Asterisk variance, sigma superscript 2 measures the spread or variability of the possible activity durations. Asterisk standard deviation, sigma the square root of the variance. It represents the typical deviation of the actual duration from the expected duration. 4. Estimating activity durations, optimistic, pessimistic, and most likely. Asterisk optimistic, A. The shortest possible time to complete the activity, assuming everything goes perfectly. This is a best-case scenario. Be realistic, but consider that all assumptions must be correct. Asterisk most likely, M. The most probable time to complete the activity under normal conditions. This is the duration you would expect most of the time. Asterisk pessimistic, B. The longest possible time to complete the activity, assuming things go wrong and encountering significant delays or problems. A worst-case scenario, but not a catastrophic one, example total project failure. Tips for estimating asterisk. Asterisk historical data asterisk if available, use data from similar past projects to inform your estimates. Asterisk expert judgment asterisk consult with subject matter experts who have experience with the activity. Asterisk team input asterisk involve the team members who will be performing the activity in the estimation process. They have valuable insights. Asterisk decomposition asterisk break down complex activities into smaller, more manageable tasks that are easier to estimate. Asterisk consider constraints asterisk take into account resource limitations, dependencies, and other constraints that may affect the duration. Asterisk document assumptions asterisk clearly document the assumptions made when creating the estimates. This provides context and helps to understand potential variations. Example asterisk. Let's say we are estimating the duration of design a website mockup. Asterisk A, optimistic 5 days, everything goes smoothly, the designer is immediately available, requirements are clear. Asterisk M, most likely 7 days, normal working conditions, some minor revisions. Asterisk B, pessimistic 12 days, the designer is busy with other projects, significant revisions are required, there are unforeseen technical challenges. 5. Creating an activity list and dependencies. This is a crucial step. You need to break down the project into individual activities and define the relationships, dependencies, between them. Asterisk activity list asterisk a detailed list of all the tasks that need to be completed for the project. Asterisk dependencies asterisk the relationships between activities, indicating which activities must be completed before others can start, predecessors. Common dependency types. Asterisk finish to start, FS activity B cannot start until activity A is finished, most common. Asterisk start to start, SS activity B cannot start until activity A has started. Asterisk finish to finish, FF activity B cannot finish until activity A is finished. Asterisk start to finish, SF activity B cannot finish until activity A has started, least common. Example activity list and dependencies asterisk. Activity ID activity description predecessors. Dash 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 dash. A define project scope none. B gather requirements A. C design website mockup B. D develop backend B. E develop frontend C, D. F test website E. G deploy website F. 6. Building the network diagram, optional but helpful. A network diagram, also called a PERT chart or activity diagram, is a visual representation of the project activities and their dependencies. It helps to visualize the project flow and identify the critical path. Common formats for network diagrams. Asterisk activity on node. On activities are represented by nodes, boxes, and dependencies are represented by arrows connecting the nodes. Asterisk activity on arrow. AOA activities are represented by arrows, and nodes represent events, start or finish of activities. AOA is less commonly used than AON. You can create network diagrams using software like Microsoft Project, Primavera P6, or online tools like Draw.io or Lucidchart. Example AON network diagram asterisk. 7. Calculating expected activity durations and standard deviation. Using the PERT formula, TE equals A plus 4M plus B, slash 6, and the variance formula, sigma superscript 2 equals B, A, slash 6, superscript 2, calculate the expected duration and standard deviation for each activity. Example asterisk. Let's continue with our design website mockup example from section 4. Asterisk A equals 5 days. Asterisk M equals 7 days. Asterisk B equals 12 days. Asterisk TE equals 5 plus 4 asterisk 7 plus 12, slash 6 equals 5 plus 28 plus 12, slash 6 equals 45 slash 6 equals 7.5 days. Asterisk sigma superscript 2 equals 12 to 5, slash 6, superscript 2 equals 7 slash 6, superscript 2 equals 1.36. Asterisk sigma equals square root 1.36 equals 1.17 days. Repeat this calculation for all activities in your project. Updated activity list with expected durations and standard deviations. Activity ID, activity description, predecessors AMBTE, expected duration, sigma, standard deviation. Dash 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 dash. A define project scope none 2353.170.5. B gather requirements A4575.170.5. C design website mockup B5712.7.51.17. D develop backend B8101410.331. E develop frontend C D6811.8.170.83. F test website E3464.170.5. G deploy website F12320.33. 8. Identifying the critical path. The critical path is the longest sequence of activities in the project network, determining the shortest possible project duration. Activities on the critical path have zero slack, or float, meaning any delay in these activities will directly delay the project completion date. Methods for identifying the critical path asterisk. Asterisk manual forward pass and backward pass asterisk. Asterisk forward pass asterisk calculate the earliest start, ES, and earliest finish, F, times for each activity, starting from the beginning of the project. Asterisk backward pass asterisk calculate the latest start, LS, and latest finish, LF, times for each activity, starting from the end of the project. Asterisk slack calculation asterisk calculate the slack, or float, for each activity, slack equals LS, ES equals LF, F. Activities with zero slack are on the critical path. Asterisk software tools asterisk project management software, Microsoft Project, Primavera P6, etc., automatically calculates the critical path. Applying forward and backward pass asterisk. 1 forward pass asterisk. Asterisk start with the first activity, A, and set its ES to 0. Asterisk F equals ES plus TE, expected duration. Asterisk for activities with predecessors, the ES is the maximum F of its predecessors. 2 backward pass asterisk. Asterisk start with the last activity, G, and set its LF to the desired project completion time, or the F from the forward pass. Asterisk LS equals LF, TE. Asterisk for activities with successors, the LF is the minimum LS of its successors. Example critical path calculation asterisk. Activity AMBTEESFLSLF/critical dash 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 A2353.170.3.170.3.170 yes. B4575.173.178.343.178.340 yes. C5712.7.5.8.3415.8412.1719.673.83 no. D8101410.33.8.3418.678.3418.670 yes. E6811.1718.6726.8418.6726.840 yes. F3464.1726.8431.0126.8431.010 yes. G123.231.0133.0133.0133.010 yes. Critical path asterisk A-B-D-E-F-G. 9. Calculating project duration and standard deviation. Asterisk project duration, TE_project the sum of the expected durations of all activities on the critical path. In our example, TE_project equals 3.17 plus 5.17 plus 10.33 plus 8.17 plus 4.17 plus 2 equals 33.01 days. Asterisk project variance, sigma superscript 2_project the sum of the variances of all activities on the critical path. Sigma superscript 2_project equals 0.5, 2 plus 0.5, 2 plus 1, 2 plus 0.83, 2 plus 0.5, 2 plus 0.33, 2 equals 0.25 plus 0.25 plus 1 plus 0.6889 plus 0.25 plus 0.1089 equals 2.5478. Asterisk project standard deviation, sigma_project the square root of the project variance. Sigma_project equals square root, 2.5478, equals 1.596 days. 10. Probability of completion within a specific time frame. PERT allows you to estimate the probability of completing the project within a certain time frame. This involves using the normal distribution, or Z distribution, to calculate the probability. Steps asterisk. 1. Define target completion time, T the time frame you want to assess the probability of completion for. 2. Calculate z-score asterisk. The z-score represents the number of standard deviations the target completion time is away from the expected project duration. 3. Look up z-score in a z-table, or use a calculator. A z-table provides the cumulative probability associated with a given z-score. 4. Interpret the probability asterisk. The probability from the z-table represents the probability of completing the project within the target completion time. Example asterisk. Let's say we want to know the probability of completing our project within 35 days, T equals 35. 1. We already calculated. Asterisk TE underscore project equals 33.01 days. Asterisk sigma underscore project equals 1.596 days. 2 calculate Z score. 3 look up Z equals 1.25 in a Z table. The value is approximately 0.8944. 4 interpret the probability. The probability of completing the project within 35 days is approximately 89.44%. 11. Addressing common challenges and limitations. Asterisk accuracy of estimates. Asterisk the accuracy of PERT relies heavily on the accuracy of the optimistic, most likely, and pessimistic time estimates. If these estimates are inaccurate, the PERT analysis will be flawed. This is the biggest potential weakness. Spend sufficient time and effort on gathering good estimates. Asterisk subjectivity. Asterisk estimates are often subjective, especially for activities with limited historical data. Asterisk complexity. Asterisk for large, complex projects, creating and maintaining a detailed PERT network can be challenging. Asterisk assumptions. Asterisk PERT assumes that activity durations are independent, which may not always be the case in reality. Also, the beta distribution used to model activity durations might not be a perfect fit for all activities. Asterisk resource constraints. Asterisk PERT primarily focuses on time and doesn't explicitly consider resource constraints. Resource leveling or critical chain project management may be needed in conjunction with PERT. Asterisk maintaining the PERT chart. Asterisk as the project progresses, the PERT chart must be updated to reflect any changes in activity durations, dependencies, or scope. 12. Code example, Python, for PERT calculation. Key improvements in this code. Asterisk clear function definitions. Asterisk calculate underscore PERT, critical underscore path underscore method, calculate underscore project underscore stats, and calculate underscore probability functions improve code organization and reusability. Asterisk uses dictionaries. Asterisk activities are represented as dictionaries, making the code more readable and maintainable. It stores duration, variances, and predecessor data. Asterisk handles successors. The code explicitly manages successors of the project so can handle diverging paths correctly. Asterisk critical path calculation. Asterisk the critical underscore path underscore method accurately identifies the critical path based on slack. Asterisk error handling, although not implemented here, adding error handling, example checking for invalid input or circular dependencies, would make the code more robust. Asterisk clear output. Asterisk the code prints well-formatted results, including activity ES, F, LS, LF, slack, critical path, project duration, standard deviation, and probability of completion. Asterisk comments. Asterisk explanations of the code. 13. Advanced considerations and extensions. Asterisk Monte Carlo simulation. Asterisk for more complex projects, Monte Carlo simulation can be used to simulate project outcomes based on the probability distributions of activity durations. This provides a more comprehensive risk assessment. Asterisk resource leveling. Asterisk combine PERT with resource leveling techniques to optimize resource allocation and avoid resource bottlenecks. Asterisk critical chain project management. CCPM. CCPM builds upon PERT by adding buffers to protect the critical chain from delays and focusing on resource constraints. Asterisk sensitivity analysis. Asterisk identify which activities have the greatest impact on the project duration and focus risk mitigation efforts on those activities. Asterisk dynamic scheduling. Asterisk PERT can be used in conjunction with dynamic scheduling techniques to adapt the project plan as new information becomes available. 14. Conclusion. PERT is a powerful technique for estimating project duration and managing uncertainty. By considering a range of possible activity durations, PERT provides a more realistic assessment of project timelines and helps to identify potential risks and opportunities. While PERT has limitations, it can be a valuable tool for project managers when used appropriately and combined with other project management techniques. Remember that the quality of the estimates is crucial to the accuracy of the PERT analysis. Using project management software significantly simplifies the process, especially for complex projects.